Good day, Professor Rizal. My name is Roshandev Daniel, and today I'm going to be talking on the game engine architecture book in which we were tasked. And so for my chapter, we learn on animation. And so we learn on the sampling and frequency key omission, which is how the animations are affected either by their weight or their structure, and how we compress it to ensure the size of it is kept, which is using curve-based compression, wavelet compression, and the fact that in games, we don't have to load every single animation, and that's why we learn on selective loading and streaming. We also learn on the animation rendering pipeline, in which there are 6 steps. Firstly is the decompression and post-extraction. And once step 1 is done, we move on to step 2, which is the post-blending, then to step 3, which is the global post-calculation, and then to step 4, which is the post-processing, and then back to the global post for step 5, before we move on to the matrix palette, before the animation is sent to the rendering engine. We also learn on action state machines, which is a way to ensure the animation moves from one state to another state correctly, such as running, one leg moving from walking state to running state. And we have 4 different methods and examples, such as the flat weighted average approach, the ogre animation, the granny animation, and the crossfades with flat weighted average. We also have blend trees, which are an expression tree or a syntax tree, where the interior nodes and operators serve as the inputs of those operators, which helps in the state of the animation. So you have binary loop blend trees, generalized one-dimensional blend, two-dimensional loop blend trees, additive blend trees, layered blend trees, and crossfades with blend trees. We also have state and blend tree specification, in which we learn on examples of the Naughty Dog engine and Unreal Engine 4, in which the Naughty Dog engine used a text-based approach, and Unreal Engine 4 allows its users to use multiple approach in creating a state and blend tree specification for their animations. So we also learn on the kind of transitions that are carried out, which are such as the pop transitions and crossfade transitions in animations, the transitions parameters, where we have to take each state and find out what is the next step before we can carry out the transition, and the transition matrix, which in real game we have to take into conclusion that not all state transitions are possible, such as from a dead state, there's no other state that you can go to when a character dies. So that's all, and thank you.